Hi everyone, welcome to the optometriosis.
In this video, we can learn about what are the protocols of refraction and testing procedures in step by step. In introduction, the most important thing in refractions are given below. First one, refraction chart. Second one, trial frame set or phoropter. Third one, contact lens. In contact lens, the patient either has no glasses or has forgotten the instructions and has reported for the examination wearing contact lens. These should be removed at least 1.5 hour should elapse before the refraction is performed. All optometrists and opticians should understand the following steps in refraction. Step 1, determine initial starting refraction, and step 2, determine the smallest line that the subject can read at least 3 or 5 letters in refraction chart. Third one, refine sphere for the right eye. Then fourth one, refine cylinder axis for the right eye if a cylinder is present or check the presence of a cylinder. Fifth one, refine cylinder power for the right eye. Sixth one, recheck sphere for the right eye and then repeat the process for the left eye.
We can see a detailed about step by step in refraction. First step to determine the initial starting refraction. First of all, we measure uncorrected visual acuity. To find the patient's unaided visual acuity like 6 by 60, 6 by 60 or 6 by 24, you can see the table. If a patient has 6 by 6 or 6 by 24 vision, we have to start a spherical power from plus or minus 0.50. Then we have to add plus or minus 0.25. Uh, use plus for hyperopic blur and minus for myopic. In next video, I will teach you a theoretical in refraction briefly. Now you can see that example, you can understand the initial starting refraction. Now I can tell you another example. If a patient's uncorrected visual acuity is 6 by 12, likely less refractive error, we can start with plus or minus 0.50 diopter. Then add is 0.25 diopter. And whenever we ready to test the patient uncorrected visual acuity, for example 6 by 60 or 6 by 24 or even counting fingers or hand motion, we have to remind that first this starting sphere, second one to add and then to proceed with cylinder test if needed. And next step is to refine spherical power. Refinement of sphere is the final step of determining the best spherical lens that gives us the clearest vision without overcorrecting. Now we can see the step-by-step procedure. After retinoscopy or rough subjective refraction, start from the approximate best vision sphere based on the patient's response. Then second, use plus or minus 0.25 lens. Present the patient with plus or minus 0.25. Then ask which is clearer, lens 1 or lens 2. If the patient says plus is clear, it means a over, minus or latent hyperopia. Then we have to add plus 0.25. If the patient says minus is clear, under minuses or myopic blur, we know. Then we have to add minus 0.25. If the patient says no difference, likely we gave a best spherical power. Then we have to stop. When we have to stop means patient has no longer sees improvement with either plus or minus. If patient get worse with any lens change, over minusing is avoided, especially in young patients. You can see that principles always prefer plus if vision is equal with plus or minus to avoid unnecessary accommodation, right? If patient is reading more letters with minus, you can accept it, but stop as soon as no further improvement occurs. If acuity is 6 by 12, you may need larger steps initially, like example plus or minus 0.5. Then we refine with plus or minus 0.25. Now we can see that example where we understand the refinement of sphere. A patient sees 6 by 12 with minus 2 diopter. We have to add minus 0.25. The patient says clearer. Even clearer, we have to add minus 0.25. If the patient get worse, then we have to go back to minus 2.25. And the third step to refine cylinder axis in subjective refraction. Refinement the cylinder axis is crucial when correcting astigmatism. This is done using JCC test, and I will upload a JCC video laterly. We have to see a steps in refinement cylinder axis. First step, the patient must already have a cylinder power -1 and appropriate access from retinoscopy or AR. Use JCC. In JCC, there are two meridians. One meridian has plus and other meridian has minus power. Then rotate it straddle the cylinder axis at 15 degree or 10 degree around the current axis. Then ask the patient which is clear, position 1 or position 2. Each position is 15 degree apart on either side on the current axis. Now you can see the table. If the patient says position 1 is clear, axis need to rotate toward position 1 and then move axis 5 degree. If the patient says position 2 is clearer, axis need to rotate towards position 2, then we have to move axis 5 degree toward position 2. If the patient says both are equal, axis is optimal, then we have to stop. Repeat JCC test after every axis change until both positions look same. It is the most important thing. Here a small tip, use smaller steps 2 to 5 degree as you get closer to the final axis. We have to use a smaller position 2 to 5 degree to closer to the final axis. If axis keeps shifting, recheck cylinder power, it may be too high or too low. If acuity doesn't improve despite axis change, it may not be a true astigmatic error. Now you can see that example. You start with -1 the cylinder at 90 degree. The JCC test is the patient prefers position 2, which is 105 degree. Then we have to move axis to 95 degree and test again. Now the both positions are equal. If patient says, then the axis is refined. In step 4, we have to refine the cylinder power. Refining cylinder power corrects the amount of astigmatism after the axis is finalized. It helps to find clarity and ensure comfort. Now we can see a step by step. As explained earlier, we have to first finalize the axis using JCC. Next, keep JCC handle parallel to the axis. Not test the axis, just testing the power. Flip JCC lens. Show two positions flipped orientation of JCC to the patient. Ask the patient which is clearer, position 1 or position 2. Each flip represent a plus or minus 0.25 diopter cylinder change. Now you can see the table. If patient says position 1 is clearer, we have to increase cell power by adding -0.25. If patient says position 2 is clearer, we have to decrease cell power by reducing 0.25. If no differences, we have to stop a cylinder power because a cylinder power is refined. After every power change, recheck the axis for possible interaction. Here the most important tip, we have to maintain the spherical equivalent. For example, if you add -0.5 diopter in cell, add plus 0.25 diopter in spherical. Don't overcorrect cylinder if patient sees no improvement. Then refinement is often repeated until no preference is reached. Now you can see that example. -1 cell at 180 degree. JCC position 1 is clearer and add -0.25. Now it became an -1.25. Then we have to adjust sphere plus 0.25 diopter if needed. Then repeat test. Patient says no different. Then we have a final cylinder power. Then step 5, checking cylinder when starting refraction is a sphere. When a patient initial refraction appears purely spherical, that is no astigmatism detected on retinoscopy or AR, you must still check for possible uncorrected astigmatism. Now we can see a step-by-step procedure. First, begin with best spherical correction, as previously explained. Then check the visual acuity. Third one, use the JCC to probe for astigmatism. Even if no cylinder was found initially, use the JCC to test. Here a common axis pair 90 degree and 180 degree with the rule and against the rule astigmatism. 45 degree and 135 degree is an oblique astigmatism. Then we have to place a JCC at one of these axis pair to the patient and ask which is clearer, position 1 or 2. Insert a small cylinder, example minus 0.25 at a preferred axis, then recheck visual acuity. We achieved a refined axis and power is improvement is noted. Now you can see that example. Patient unaided vision is 6 by 24 in retinoscopy plus 1.50 spherical with no cylinder, and after refining sphere acuity is still 6 by 12. Then applies JCC at 90 degree and 180 degree. Then patient prefers one position. We have to insert minus 0.25 sill at 180 degree. Now you can see the patient needs a cylinder, and we achieved a 6 by 6 visual acuity. And I will give you a small tip. The hyperopic patients may mask small cylinder due to accommodation, and always double check monocular visual acuity because sometimes astigmatism is relieved only in one eye. And step 6 to recheck the refraction or final sphere refinement. In this step, this is the last step of subjective refraction. Once cylinder axis and power are finalized, you recheck and refine the sphere to ensure maximum clarity and patient comfort. In this last step, we have to achieve a sharpest vision and optimal comfort, no over minusing or over plusing. Now we can see a step by step procedure. First, present plus or minus 0.25 lens again. Then ask the patient which is better, lens 1 or lens 2 or no difference. If patient says plus 0.25 is better, it means over minuses or latent hyperope, then we have to add plus 0.25. If patient says minus 0.25 is better, it means under minuses or need more minuses, then we have to add minus 0.25d. If patient says no differences, we achieved a best correction and then stop. Then we have to monitor a visual acuity. Here a small key point, always favor with plano or plus if no differences, and don't over minuses. Make sure you didn't introduce extra blur from astigmatism correction. If visual acuity is improving despite changes, consider pathology or amblyopia. When we have to repeat, if cylinder was changed significantly less or equal to 0.50 diopter, we have to recheck sphere again after cylinder refinement. This is because of spherical equivalent may shift. Here a final check example. Now you can see final refraction is minus 2.25 minus 0.75 into 90 degree. We have to insert plus 0.25 to the patient. The patient says blurry, then we have to insert minus 0.25. The patient says clearer, then we have to add minus 0.25 sphere. The new sphere is minus 2.50. The final RX is minus 2.50 minus 0.75 at 190 degree. And this is the flow chart. It contains a summary of a refraction protocol from the RVACC refraction testing procedure manual PDF. A full detail about a step-by-step procedure of refraction is given by a small flow chart. You can remember it easily. And that's all. Today we learned a full detailed about the protocols of refraction and step-by-step procedure of refraction. Let's meet you in next video. Thank you.